This video is on section 3.1 notes, angle measurement. So first we're going to talk about how to label angles, and to do that we'll need to know what a few different vocabulary terms are. So an angle is a measure of the size of the opening between two intersecting lines in terms of degrees. So here we've got our two intersecting lines, and then this part right here, the shaded part on the inside, is the angle measurement. The vertex is the point of intersection between the two lines that creates an angle. So this right here is the vertex, and then the sides are the lines that form the angle, right here and right here. When you name an angle, there's three ways to do it. One is to take the letters that mark the ends of the two line segments that make up the angle. So you could say A, B, C, or C, B, A. Another way to name the angle is to use just the letter for the vertex, so this could be angle D. Another way is to use the letter that makes up the inside of the angle, so this could be angle E. So if we were to name this angle in as many different ways as we could, we would say one way is angle XYZ, angle XYZ. Another is ZYX. Another way to name this angle is to call it angle Y. And the last way is angle U. Next, we'll talk about measuring angles. So we have three different measurements, and they just get more and more precise. So the first measurement, the most common, is a degree. It's the basic unit of measurement of angle size, and it's denoted with a little bubble, a degree symbol. The next more precise unit is a minute. 1 degree is divided into 60 minutes, and it's denoted with a little line, so 60 minutes. If you're getting even more precise, then you can count the seconds. 1 minute is divided into 60 seconds. You denote it with 2 little lines. So in this context, minutes and seconds are not related to time units, but mathematically they work the same way. So once you have, if you had 70 seconds, you would say that's a minute and 10 seconds. And you're talking about degrees, but it still works the same way you think of time numbers. So here we have some pictures of different degree measures. A full circle is 360 degrees. A quarter of a circle is 90 degrees. Over here they have a picture of 10 degrees. If you were to write a number for an angle measurement that was 62 degrees, 12 minutes, and 37 seconds, they would write it like this. And so if you saw something written like this, you would say 62 degrees, 12 minutes, 37 seconds. Is that angle measurement. And that's just being very precise. If you weren't being this precise with it, you could say a little bit more than 62 degrees. That angle is a little bit bigger than 62 degrees. All right, so here they ask you to find the sum of a couple different angle measurements. They're asking you to add them together. So here, 33 degrees, 17 minutes, 48 seconds added to an angle that is 74 degrees, 12 minutes, 32 seconds. And we just combine the parts of the units that are the same amount of precision. So 33 degrees and 74 degrees are going to be added together. 17 minutes and 12 minutes are going to be added together. And then 48 seconds and 32 seconds are going to be added together. So 33 and 74 is 107 degrees so far. 17 minutes and 12 minutes is 29 minutes so far. So degrees, minutes. And then we have 80 seconds. Now 80 seconds is enough seconds to take 60 of these seconds and bump it up to a minute. So I'm going to take away 60 of the seconds and leave 20 behind. And then I'm going to take those 60 seconds and say that was actually 1 more minute. So when I add these together, I have 107 degrees, 30 minutes, and 20 seconds. All right, if we do it again, I'm going to combine the units that are the same level of precision. So 56 degrees and 10 degrees, 59 minutes and 38 minutes. And then 35 seconds and 43 seconds. So that's 66 degrees, 97 minutes. Now these 97 minutes have 60 minutes inside of here that can be added as a degree. So I'm going to subtract 60, that's going to leave me with 37 minutes, and those 60 minutes are going to become one more degree. Okay, 35 seconds and 43 seconds, 78 seconds. Of these 78 seconds, 60 of them can bump up and be added as another minute. So I'm going to take away 60 seconds. That leaves me with 18 seconds. And then 60 seconds is another minute. So 67 degrees, 38 minutes, 18 seconds. All right, here we're looking at a protractor, and we're going to see different ways to measure angles using the protractor. So when you're using a protractor on the page, you can measure from the right side. You can have an angle like angle DOE that's on the right side of the protractor, or you can have an angle that's on the left side of the protractor. It doesn't matter, but it is going to change how you measure the angle. So the most important thing is that you take the protractor and the little circle right here, you line up with the vertex of the angle, and then this bottom line right here that's labeled as a 0, either on the left or the right, has to be one of the sides of the angle. So this is the vertex, this has to be one of the sides, or this has to be one of the sides. And as long as you've done that with your protractor, you can measure the angle correctly. So I'm just going to go through and measure. These two measure from the left and these two measure from the right. So the first angle we have is angle AOB. And so we're starting here, we're going to start at 0 and measure up to B. So 10 degrees, 20 degrees, 30, 40. It's between 40 and 50. And I have to look close. It looks to me to be at about 45, right in the middle. So measure of AOB is 45 degrees. Measure of AOD, so starting at 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, going all the way over here to 120. So this is a 120 degree angle. And it already has the bubble, so I don't need to put a little degree sign. Okay, if we go over here and look at BOE, I can't start on the left side because this is not starting at 0. So I have to go over here and start on the right side at 0. I can't start right here because this starts at 180 and then 170 and then 160. Again, it's not starting at 0, so I have to use the underside of the protractor. So whenever I count my degree measures, I always have to start at 0. So BOE is going to start here at the E, 10, 20, 30, 40, 50, 60, 70, 80, 90. It's going to go all the way over here to the B, and it's right there between 130 and 140, and it looks like it's right there in the middle, so it's 135. And then DOE is right here, and I have to start at 0, so I'm going to be working on the inside. 0, 10, 20, 30, 40, 50, 60 for DOE. All right, next we're going to talk about classifying angles, and what they mean by that word classify is just to describe what type of angle you have. So there are typically 4 different types of angles that we look at. The first is acute angle. An acute angle is an angle whose measure is less than 90 degrees. So you can see 90 degrees right here is that like perfect corner shape, a number that's or a line that's straight up and down, a number that's left and right. So that's 90 degrees. So an acute angle is anything that's smaller than that. So these are all acute angles. Obtuse angles are angles whose measure is greater than 90. So they're greater than a perfect corner, like a corner of a table or a corner of a piece of paper or whatever. A right angle is an angle whose measure is exactly 90 degrees. I'm going to ignore this for a second. And then a straight angle is an angle whose measure is exactly equal to 180 degrees or exactly equal to a straight line. So acute angles, obtuse angles, right angles or 90-degree angles, and then straight angles. 90-degree angles or right angles are created by perpendicular lines, which are lines that intersect at a 90-degree angle. So down here in this example, they ask you to classify each of the following angles, and when they say that word classify, they're just asking you to write one word that describes them. So this is an angle that is smaller than 90, so I would say acute. Again, smaller than 90, so this is acute. This is bigger than 90 degrees, so I would say obtuse. This angle looks like a right angle. Typically, when it's a right angle, they'll put a little box right here, and then that's how you know. So I would say this is a right angle. This is a straight line, so I'm going to call this a straight angle. This one looks very close to 90, but still a little bit less, and so I'm going to call this acute. So that's all they mean when they say classify the angle. All right. Next, we have specific types of angles that happen when 2 lines intersect. So the first type of angle we have is called a vertical angle, and these I think of as the angles that kind of correspond to each other on either side. In my mind, I think of it as an X, but it's just, 2 lines are crossing and it creates an X. So these angles look the same. It's the big angle and the big angle. And what we find is that these 2 angles are congruent, which means that their measurements are equal. They're the same angle measurement. And so these angles right here are also congruent. Those are also the same. So these are called vertical angles. These are called vertical angles. And then the next angles are called adjacent angles. Those are the angles that are next to each other. So B and C are adjacent angles. C and D are adjacent angles. A and D are adjacent, and A and B are adjacent. And these adjacent angles, you can see that they always form a straight line, which means they create a straight angle or a 180-degree angle. So whenever you have 2 lines that cross like this, you can pretty easily tell what all of the angle measurements are if they give you at least one of them. And then we talk about triangles. If you have 3 intersecting lines, you form a triangle, and triangles always have 180 degrees inside of those 3 intersecting lines. Okay, so here we have 2 intersecting lines. They told you that this was 40. So as soon as you know that this is 40, then you can say, well, these 2 angles are vertical angles, and so they must be the same. So this over here is 40 as well. And then you can say, well, these 2 angles right here are adjacent angles, or that the 2 of them form a straight angle, which means they have to be 180 degrees altogether. And 180 degrees take away 40 degrees is 140 degrees. And so this angle right here must be 140 degrees. And then B and C are also vertical angles. They're just a different pair of vertical angles. And so those 2 have to be the same. And then pretty easily we were able to tell what all the angles were. So the measurement of angle A is 40 degrees. The measurement of angle B is 140. The measurement of angle C is 140. In this picture of a triangle, we have the measure of angle P is 50 degrees. The measure of angle Q is 85 degrees. And if we want to find the measure of angle R, we just have to keep in mind that all three of these angles add up to 180 degrees. So we can do 50 degrees plus 85 degrees plus angle R is 180 degrees total. So 180 minus 50 minus 85 means that angle R is 45 degrees. All right, we also have more angle relationships when we talk about two parallel lines and a transversal. So two parallel lines, that's these two lines right here, and then the transversal is just a line that intersects two other lines. And oftentimes when you have two parallel lines, they'll put little markings on them that look like this, so you can tell, oh, these two lines are parallel. It's pretty common for them to do that. I haven't seen it in this textbook as much, but in other math textbooks you'll see that all the time. Now, when you have two parallel lines and a transversal that cuts into them, you'll notice two things about the angles. One is that alternate interior angles are congruent. So when we talk about the angles that are in between the parallel lines, the angles that are alternating sides of each other are the same. So angle E is the same as angle D, and angle C is the same as angle F. So that's one thing we'll notice. I didn't draw that very nice. I just made it worse. Sorry, I'm going to fix that before I move on. The other thing we'll notice, that's a little bit better, is that corresponding angles are also congruent. So corresponding, if I look at this as 4 angles and look at this as 4 angles, then I could say, well, the top right is the same as the top right. The bottom left is the same as the bottom left. The bottom right is the same as the bottom right. And the top left is the same as the top left. So we end up, if we know one of the angles out of all 8 of these, we'll end up knowing all of them. And then you can also see from the previous picture we had, if we ignore this bottom line, we've got our vertical angles that are the same. And then we also have our adjacent angles that are on a straight line. So the angle relationships that we saw here are still true. Okay, so let's look at the next page. And they show us, we've got the pictures of alternate interior angles. We've got the pictures of corresponding angles. And so now let's go ahead and look at a picture that asks us to solve for everything based on what we know here. So if this is the upper left, then we know that the upper left is also 70 degrees. Upper left is 70, upper left is 70. If this is 70, then we know that on a straight line, these two are going to add up to 180 degrees. So I can just do 180 degrees minus 70 degrees. I get 110. Well, I can say 110 degrees. This is the upper right number. So upper right, those are going to have to be the same. So what I just did is I was using the relationship of adjacent angles because they add to 180, and I was also using the relationship of corresponding angles. Well, now I can use the relationship of alternate interior angles, and I can say if this is 70 degrees, then the alternate interior angle, the angle that's on the opposite side but still in the middle, is also 70. So this is 70. And if this is 110, then the angle that's on the opposite side, but still in the middle, is also 110. And then I can go ahead and I can do corresponding angles again. This is the bottom right side, so the bottom right side is 70. This is the bottom left side, so the bottom left side is 110. And there I have labeled every single angle in the picture, and I can go through and just write them down. So P is 110, R is 70, T is 110, W is 70, Q is 110, S is 70, U is 110. All right, in this example it says a plumber connects two vertical sections of pipe. So here's the two vertical sections of pipe. Connects them with a 30-degree elbow. So here is a 30-degree elbow that they labeled with angle A. What angle does X, what is the angle of X that this makes with the upper pipe? So what I'm going to do is I'm going to extend these lines so that we can see that we have two parallel lines. If they're talking about two pipes being vertical, then they are likely like perfectly straight up and down, and so they're probably parallel. And then this pipe right here is your transversal. Okay, so here's your two parallel lines. Here's your transversal. So this is 30 degrees. You can see this right here is a 90-degree angle. So if we have a 30-degree angle and a 90-degree angle, then that means that the whole angle right here is 30 and 90. It's 120 altogether. So we have two parallel lines, we have a transversal, and we have this is 120 degrees, and we're trying to find this. This is angle X. So if we use what we just learned, we know that alternate interior angles, the angles that are on alternate sides on the inside of parallel lines, that they're the same measurement. So that means that this angle right here must be a 120-degree angle as well. So angle X is a 120-degree angle, and the reason we know that is because we have alternate interior angles. Alternate interior angles. All right, in the pipe flange, I think that's how you say that, shown below, the 8 bolts are equally spaced. How many degrees apart are the bolts? So they're showing you this is the degree measure they want. So they're equally spaced. So we've got a circle here, so I know that all the degree measures in the whole circle, that's 360 degrees. And I've got 1, 2, 3, 4, 5, 6, 7, 8 spaces. So 360 divided by 8 spaces that should all be equal in measure is 45 degrees. So each of those should be 45 degrees apart.